Today we're going to talk about the real number system. While I don't expect you to watch every moment of this video, you do have to complete every single problem on the worksheet, and this video will walk you through all of the odd problems. My suggestion would be that you listen to this video to take down all the notes, and when we actually start the numbered practice problems, you try the odd ones on your own to see how well you understand the content, and you use the video to check your answers. And that way, whenever you do the even numbers, which you don't have help with, you will be more confident in your answers. So let's go ahead and get started. Here are your learning targets for today. If you want to pause that and read it, you can. This is what the worksheet looks like that we're looking at. If you have the ability to print this off, I would recommend printing it and taking notes directly on the worksheet. However, I know that not everyone has access to a printer, and that is perfectly fine. You are welcome to just take notes on notebook paper. Not a big deal. But today we're only going to look at the front of the worksheet. So if you're looking at the file on the computer, that's just page 1. We'll look at page 2 on assignment number 3. Okay, so let's dig in. Real numbers. Real numbers are represented by the letter R, a capital letter R. That's important that it's capitalized. And real numbers consist of the following subsets of numbers. So there are irrational numbers and rational numbers. Those are the two big sections. And we're going to use a graphic organizer to visualize this a little bit better. But irrational numbers are numbers in which the decimal form never terminates, so it goes on forever and ever, and does not repeat. Common examples are pi and non-perfect square roots. All right, and then we have rational numbers. Rational numbers are numbers in which the decimal form does terminate or does repeat. Rational numbers can always be written as a fraction where a and b are integers. And we're going to learn what integers are right here. So there's irrational and rational numbers, and then rational numbers are broken down into 3 more types of numbers. Integers is the biggest subset. And integers, I call these number line numbers. These are the ones whenever you went to your first, middle school math class, they probably had a number line up that went from -10 to +10, and it counted by ones. Those are the numbers that are integers. So any whole number, positive or negative, and it includes 0. So whole numbers are only the positive numbers and 0. So 0, 1, 2, 3, 4, 5, etc. And then natural numbers, I like to think of these. So whole numbers include 0. And natural numbers, these are like what you teach a baby to count. Whenever they're a toddler and you teach them to count, you don't start with 0. You start with 1, 2, 3, 4. We naturally start at 1. And so that is the set of natural numbers. These are what you would teach a baby. That's just how I remember these things. You guys can come up with your own little tricks and whatever you want to. So let's use what we talked about to kind of organize these in a chart. So on the left, we have a chart or a diagram. And the box represents all real numbers. So we're going to put an R in that box for real numbers. Then we remember that real numbers there are 2 types of real numbers. There are irrational and there are rational. So irrational does not have any subsets. And the letter that represents it is I. So this little circle to itself is represents irrational numbers. I'm going to go ahead and give you the letters that belong in this chart so that we can look at those. So rational numbers are represented by the letter Q, R is already taken for real numbers, so we had to use something different. I didn't get to pick these. Someone much smarter and older than me did. Integers are represented by Z. Whole numbers are represented by a W. And natural numbers are represented by an N. So, remember, so we've got all real numbers in our box. Then we have irrational and rational numbers. Rational is a Q. So that's the two big circles. Now, inside of rational numbers, we have integers. And remember, integers are our number line numbers. And then within integers, if we take out all the negatives, we're left with whole numbers. That's 0, 1, 2, 3, 4, 5, etc. And then if we take off the 0, we're left with natural numbers. So this just shows you that if a number is a natural number, that means it is also a whole number, an integer, a rational number, and a real number. So these are nested inside of each other, and they tell you that this helps you identify what sets a number belongs to. So let's look at some examples of all the different types of numbers. Irrational numbers, remember, the decimal form never terminates and does not repeat. So we know that pi goes on forever and never repeats, so that would be an example. The square root of 5, if you were to type this in your calculator, it would give you a big long number just like pi does. It would never repeat and it would never end. The square root of 72 is another odd one. The square root of 41 is another odd one. So the easiest way to tell a rational number is to type it in your calculator and see what the decimal form looks like. Okay, then we have rational numbers. Rational numbers can be decimals that have an end, so like 0.34. If that's the answer, you didn't have to round to get there, then that is a rational number. Rational numbers can always be represented as a fraction. So if you have 1 5/8, that is rational. They can also be decimals that repeat. So 0.2 repeating, that is a rational number. And rational numbers also include negatives. So if we had negative 7/11, that would also be a rational number because it can be represented as a fraction. So integers. Remember, integers are our number line numbers. So let's say 7, for example, is on a number line. Something else we need to look at is like negative square root of 100. Okay, if we were to reduce a number like this actually equals negative 10. So you have to watch out in these practice problems and make sure that these numbers are written in their simplest form before you assume that this is irrational because we saw a square root sign. 0 is also an integer, and fractions that reduce to whole numbers. So 8/4, that reduces to 2, and 2 is an integer. Okay, next we have whole numbers. Whole numbers include 0 and anything that reduces to a whole number. So 20/4, that would reduce to 5. The square root of 16, that reduces to 4. And big numbers too, like 90. Like that's a whole number too. Whole numbers are all integers except negative numbers. And finally, natural numbers are your counting numbers. So 10, 47, the square root of 9 reduces to 3, that's a counting number. Or 34/2, that equals 17, that's a counting number. Okay, so I hope this helps you get the picture of what some of these look like. Now, this is the part where I said you could probably stop and practice on the odd numbers. Go try to do them on your own, then come back to the video to check your answers. And if you do well on the odd numbers, then you can be confident that you'll do well on the even as well. So I'm going to go ahead and start going through the odd numbers. I would suggest you pause here and try them before you watch the rest of the video. Okay, so first we're going to make sure, I'm on number 1. I'm going to make sure this is as simple as it can be, -10. That doesn't reduce or change in any way, it just is what it is. So I'm going to ask myself, I'm going to look at my diagram, and the biggest set is real numbers. Is it a real number? Yes, it is. So it definitely belongs to the R set. So this asks us to name all sets to which it belongs. So now I'm going to go in, and I have to decide, is it rational or is it irrational? Well, so in decimal form, it does not, like if it doesn't end or doesn't repeat, then it's irrational. Well, -10 doesn't even have anything after the decimals, so it's definitely rational. So remember that rational is represented by Q. And then within rational, we need to look at integers. That's the next biggest group. Is -10 a number line number? And yes, it is. So it's going to get a Z as well. And then the next section the next biggest subset is whole numbers. Remember, whole numbers start at 0 and include your positive number line numbers. So that's 0, 1, 2, 3, 4, 5, etc. It does not count negatives. So since it's not a whole number, it cannot be a natural number, because natural numbers are all included in whole numbers. So once you get to the Z, you can stop. RQZ would be your answer for number 1. So number 3, whenever I look at this in fraction form, I automatically know that it has to be rational, because if it were irrational, it couldn't be written as a fraction. But also, so that you can picture this, if this were written as a decimal, it would equal 1.7 repeating. Okay, so you can look at it either way, whichever makes more sense to you. So if we know that this is a rational number, that means it has to belong to the real numbers too. So we know for sure we have RQ. The next subset is integers, and those are number line numbers. On a traditional number line, think elementary classrooms. Don't think about advanced math. Think about normal, like classic number line. Is 1.77777 on that number line? No, it's not. So this does not belong to the integer group, and we can stop with RQ. That is all the sets that this belongs to. So number 5, 2.48. This is a decimal, and it terminates, it ends. There's no repeating on it. So it is definitely a real number, and it is rational because it has an end, and it doesn't it doesn't matter if it repeats because it ends. So 2.48, it seems like a semi-normal number. So in my mind, that's kind of how I look at it. Like, this is a normal number. Like, it's not some big ridiculous decimal. So it's probably rational. So number 7, pi minus pi. Now, something we need to think about. Pi is an irrational number because it never repeats and it never ends. However, pi minus pi equals 0, because anything minus itself equals 0. 2 minus 2 is 0. 700 minus 700 is 0. So pi minus pi is also 0. So we are actually classifying 0. So 0 is a real number. It's also a rational number. And it is on a traditional number line, so it falls into the integer category. And whole numbers start at 0 and go up. They're the positive number line numbers, but they do include 0. So it's also a whole number, but remember, natural numbers are our counting numbers that you would teach a baby. You don't teach a baby to start at 0. You start with 1 and then go 2, 3, 4, etc. So 0 is not a natural number, so RQZW is your final answer for 7. All right, 0.15 repeating. Okay, so in your calculator, this would look like 0.1515151515, blah, 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 blah. Okay, but we know it repeats, so we don't have to actually look at it like that. All right. So repeating decimals, we know those are real. And then we have to look at rational or irrational. Well, irrational numbers don't repeat and never end. This one repeats, so it must be rational. Then we have integers. And integers, remember, are your number line numbers. 0.15151515 does not show up on a traditional number line. So RQ is your final answer for number 9. Finally, number 11. You can look at this as a fraction, -8/3, or you could type it in your calculator, see it as a decimal, and find that it's -2.6 repeating. Then so now we need to decide, we know it's real. We need to decide if it's rational or irrational. Remember, irrational numbers never repeat, so this has to be rational. And then the next category to check is integers. Is this a number line number? 2.666666 does not show up on a number line. So the RQ is your final answer for number 11. Okay, that's the end of the video. You are supposed to turn in all of this page, so the notes at the top and numbers 1 through 12 should all be finished. I've given you answers to the odd problems. You need to complete the even ones and copy these down as well and submit the completed worksheet, or complete all that stuff on notebook paper and submit that. Thanks so much. Have a good day.